Good morning, everyone. My name is Ruomeng. I'm from the University of Edinburgh. I hope you all stay well in pandemic. Today, I'm going to talk about synchrony and asynchrony of the two eyes in binocular fixations in the reading of English and Chinese, the implications for ocular prevalence. So the big question we're going to ask here today is, are the two eyes doing exactly the same thing? So first, we're going to have a look at a video in the reading of Chinese and observe how the two eyes behave and coordinate in the reading process. This is from our eye tracking experiment, and the pink one represents the right eye and the green one represents the left eye. Okay, as you can see, the two eyes are not performed in the same form. So what we're trying to discover here is when the two eyes are doing different things. So there are two important concepts we need to introduce first: ocular dominance and ocular prevalence. Ocular dominance, which is well known by most of people, is related to your dominant eyes. It indicates one eye is preferred in sighting task, and the binocular fusion is not feasible because of a difference in input. On the other hand, the ocular prevalence means one eye's input is weighted over the other eye's input in conscious perception after the binocular fusion, which indicate that the brain is trying to adjust the weighting of two eyes' input and create an optimal product for the visual perception. So the ocular prevalence is relatively evenly distributed between the two eyes. And we assume that the prevalence of one eye's input may be because the target is closer to that eye or is located substantially on its side of the midline. Therefore, our hypothesis today is the left eye will tend to begin fixating earlier and stay fixating longer in the left visual field, and conversely for the right eye in the right visual field, and thereby facilitating appropriate switching of ocular prevalence. So here's our data information. There are 36 Chinese and 38 English native speakers, and there are around 5,000 words text for each language. And we collected more than 300,000 fixations. And for each binocular fixation, the start time and end time of fixation was recorded for each eye, just like shown in the previous video. And we use general linear mixed effect models for the quantitative analysis. And our analysis is to discover what are the two eyes doing in terms of time. So we classify two types, synchronies and asynchronies. Synchronies means start and end of fixation is aligned in time for the two eyes, just like this diagram shows. That we have our left eye and right eye start fixating together, and then both eyes stop fixating together. On the other hand, asynchrony means start and end of fixation is not aligned in time for the two eyes. Just like this diagram shows, we have our right eye start fixating earlier, and then both eyes stop fixating together. Another example of our asynchrony is the left eye start fixating together, and both eyes stop fixating together. Based on this analysis, there are 9 different possibilities for all the binocular fixations. So here we have our synchronized and we have our 8 different asynchronies. And we classify left prevalent types, which is type 1, type 6, and type 7. They all have slightly longer left eye fixations at the beginning, at the end, or at both sides of the fixations. We also have our right prevalent types, type 2, type 3, and type 5, which have slightly longer right eye fixation at the end, at the beginning, and at both sides of the screen, of the fixation. So what did we find based on this analysis in reading Chinese and English? So this is a plot of the distribution of our 9 types in English and Chinese readers. The first thing we will notice is the synchronized types, which occupy over half, which is like over 50% of the distributions in both languages. And we also notice that the T3, type 3, and T6 shows predominant distribution across 2 languages as well. And in general, we can see that there are strikingly similar patterns in the reading English and Chinese. And we further explore the spatial distribution of the types in English readers. So this is a spatial information of our binocular coordination divided by our 9 different types in terms of our mean X and mean Y, horizontally and vertically. And the counts indicate the frequency of the distribution spatially. And the legend here indicate the frequency from the low to high. As you can see that the synchronized T3 and T6 shows the greatest density according to their number of the data sets. And we have our synchronized types distributed across the line. And we have our T3 as a red prevalent types concentrate at the right side of the screen. And we have our T6 as a left prevalent types concentrate at the left side of the screen. And interestingly, we also find that all the left prevalent types, T1, T6, and T7, all shows left side concentration, while the right prevalent types, T2, T3, and T5, all shows the concentration at the right side of the screen. If we have a look at the spatial distribution in Chinese reader, we'll find a very similar pattern here as well, with the left prevalent types, T1, T6, and T7, concentrate at the left side of the screen. And T2, T3, and T5 as the right prevalent types concentrate at the right side of the screen. So what does this tell us? Here's our results and conclusions. First, both languages yield very similar results despite very different orthographies. Just as saw in the previous plots, that we can see very similar patterns happens in both languages. And the Chinese data we find are somewhat more systematic compared to the English data. The synchronized pairs type 3 and type 6 predominant, just like what we can see in the previous plot, and they all have synchronized offsets at the end of the fixation. And the results from the general linear mixed effect models shows that the left eye priority types T1, T6, and T7 statistically gather at the left side of the screen, while the right eye priority types T2, T3, and T5 quantitatively gather at the right side of the screen. We suggest one eye begin fixating earlier can cue a switch in ocular prevalence to that eye, and one eye is fixating longer can confirm that eye's ocular prevalence. Although the difference between the 2 eyes are very small, we still discover an interpretable, predictable pattern across 2 very different orthographies. So peripheral, low-level ocular mechanism can affect high-level processing like ocular prevalence. And in summary, we have shown that the very fine-grained mechanical behaviors involved in reading can connect via ocular prevalence to the conscious perception of the text. Okay, that's the end of the talk. I hope you all stay safe, and thank you very much.